I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have
They're trying to frame a point of view. Say when you something, and I can see some flushing your feet from the map. Loved by you.
When Maggie and we just played, these little sort of keep it brief, quick in. Over 30 years, helping consumers with auto claims and repairs. Now for the first information about how effective the drugs are in preventing infection or serious illness. More there.
All right, welcome back to the final episode on the 10R86, and we've already done the final episode on the Cobra-matic. So what's left to talk about, you might say? Well, nothing left to talk about with this. I think I'm done with that. This guy, as you'll recall from the earliest episodes, had some heat problems. And one of the things, there are two things I wanted to do. The 6v6 output tubes here have a common cathode bias. So I want to check the cathode voltage and current and make sure they're not being overdriven. They may or may not be. The second thing is, this is a 110, 115 volt chassis, and it's the line voltage is right now 123 volts. So there's one resistor that I want to look at to drop the internal voltage just a bit. And so that's what I want to talk about in this video, is checking the bias on the driver tubes, checking the B plus voltage inside and seeing if we can reduce that a little bit, because our line voltage is 10 volts higher than it used to be in 1951. What we want to do is lower the B plus voltage that runs around in here by some amount. And what we know is what B plus should have been when line voltage was at 110. Now it's at 124, and I want to make sure that the line voltage, the B plus inside here, isn't much higher than it should have been in the first place, which was around, where's my schematic? Oh, we were feeding, boy, it's hard to read. Here's the rectifier. Here's a 130 ohm resistor, and feeding the center tap right here of the output transformer with, it looks like 335 volts, something like that right there. I'll have to go back and check that to make sure that's right. We know that on this side of what used to be the CAN dome, we should have 260, and up in here, 260 volts. Then up in here, keep in mind that this has two sets of filter caps. Right here at this point we should have 220 volts DC. So what I want to do is go and measure. Well, let me switch to the online schematic, and I'll show you why I'm even concerned about this, or not concerned, what the issue is. What's the issue? Well, the issue is that this chassis was designed to have 115 volts AC right here, and that would produce 340 volts of DC going into the filter caps. Now there's 124, 125 up to 127 volts AC here, and that changes this voltage right here quite considerably. Normally, admittedly, you would put the dropping resistor over here in the hot side of this to drop the voltage across the primary of the power transformer. In this case, it seemed a little easier. This is a flaky resistor anyway, and the 5Y3 is capable of handling quite a lot more voltage than it is in this situation. So what the situation is that 124, 125 volts right here produces 380 right here instead of 340. So it's 40 volts high, which means that the B+, which is generally here and goes out to all the rest of the radio, is a lot too high. So what we need to do is change this resistance, this 130 ohm resistor, to drop this. The target voltage for this guy right here is 325 volts. I'd be happy with anything in that 325, 330, 335 even. I'd be happy with that. So we've got 380 coming in here. We've got to get to 325, 330 here. How does this resistance change? So that's what we're going to take a look at. Here's the current flowing through these. In order to drop this 340 volt DC down to 325 with a 130 ohm resistor, Ohm's law says it has to, the current flowing through here has to be 0.115 amps or 115 milliamps. But interestingly enough, to drop the voltage from this 325 to 280 volts across this 1K resistor requires 75 milliamps. And that means we've got one current flowing through here and a different current flowing through the center tap of the output transformer primary. So this gets into a really interesting application of Kirchhoff's law, which I can't, I can no longer spend all the time trying to figure out all the components that would make up a return to ground here. So all I can do is say I've got 0.115 amps through this 130 ohm resistor. In an ideal world, what's it going to take? If this goes to 380, which it is now, how can I get this 380 down to 325? Well, let's take a look at that. So in an ideal world, this is what we would do. Our voltage right here, 124, 25 volts, instead of being the nominal 340 is now 380, which gives us a lot bigger voltage drop to get down to 325 volts. So just, if this were just a straight series circuit, we do this. We do the resistance that we want right here is the voltage divided by the current. And the voltage in this case, we want a 380 minus 325 volt drop at the current of 115 milliamps. The resistance we want is 55 volt drop divided by 115 milliamps, and that gives us 478 ohms. So in a perfect world, if we dropped a 478 ohm resistor right here, we'd have 325 volts here, and everything else in the circuit would remain the same. However, it don't work that way because this is not a simple series circuit. This is a parallel series, who knows what else, inductors, everything else circuit, because recall this goes off to the center tap of the primary of the output transformer, and it's being kicked around by the output tubes. And all kind of other stuff hanging around in here. So the way to approach this, the way I chose to approach it, is I said, okay, 478 ohms. What I'll do is drop as close to that as I can get right there and see what happens. And what happened was this 325 dropped down to about 314, 315. And what I did was take the power resistors that I had to see what it would take to come up to about this. And what I ended up with was the 260 ohm resistor right here that got this to 330, which was close enough for me. So the currents change a bit, not a lot, but a bit. The current, if you raise this to a 360 ohm resistor, the current drops down to below 100 milliamps. But keep in mind there's a strange, I don't know what to call it, truth, I guess, about tubes. And tubes, the truth is that tubes are driven by voltage. I remember when I was in school 100 years ago, tubes were driven by voltage, transistors were driven by current. And that's still mostly true. So what tubes want to have around is voltage. And currents drive transistors. So this is obviously a tube circuit, so we care about voltage. And what I want is this to be as close to 325 volts as I can get it. And it turns out that a 360 ohm resistor right here, with this current differentiation between what goes up here and what goes out here, gets me to 330 right there. So that's fine with me. That works for me. So what I did was I used Ohm's law to get to a value, and then I adjusted downward from that value to get to where I wanted to be, and that was 360 ohms. So that was my approach to this whole problem. Well, problem is the wrong word. It's an opportunity. Okay, the resistor is in, the set is on. See what kind of voltage we get. Again, this is an insulated case, so fairly low risk putting it right there. Let's see what's happening with our new resistor. .330 volts on that side. And 375 on that side. So that did it. Our previous measurements had 380 on the one side and 333. We've got we're putting in 123 volts AC. We've got 330 volts on the 330 volts on this side of this resistor, which is just what we want. And so our B plus is back into the normal range. If we look over here on the other side of this 1000 ohm resistor, we should see about 260. Let's see if that's in the ballpark. I think it's this guy right here. Yeah. 264. So that looks very good. So that is solved. We've got an appropriate B plus floating around in the chassis. Again, the rectifier tube, the 5Y3, is rated for a higher voltage and amperage than it was using originally, so it's fine. Usually dropping resistors are done on the input side of the primary side of the power transformer, but in this case it was easier to do it on the after the rectifier did its job. All right, that's good. Just where we want it to be. The next thing I want to check real quickly, and then we can be done with this radio, is this voltage right here. This is a 6V6 push-pull Class AB amplifier, and it has a 270 ohm resistor right here, 2 watt. Should force the cathode to 17 volts. This is cathode biased, and that's 62 milliamps, which is, within, I think it's 70 or 80 milliamps for current through there. So 62 milliamps would be fine. So all we have to do is check that voltage on pin. I think that's 8. No, yes, 8. Pin 8 of the 6V6s. And if we've got around 17 volts, we're good. And we're not stressing the 6V6 output tubes. Pardon me. So, let's see if I can spot pin 8 of either one of these. One, 2, 3, 4, 5, 6, 7, 8. So it should be right there. 16.707. So that's good. Okay. Biasing on the 6V6s is conservative. That will do it. We're done. We're done with the radio. Done with the phonograph, done with the radio. The next thing up, I guess, is the chassis for this one. And the weather is warming up here, so we'll work on that. Till next time, see ya. Take care of yourselves. Bye.